Welcome to our webinar, Klaveness's Experience with Shipshave ITCH Ship Hull Grooming Device, 5% fuel reduction from our sponsors, Shipshave. Our guest speakers today are Erik Eder, Chief Commercial Officer and co-owner of Shipshave, and Anders Soheim, Sustainability and CO2 Performance Manager from Klaveness. If you have any questions about the topics today, please type them in the Q&A section and we'll get them answered for you at the end of the presentation. Here is our host, Carl Jeffrey from Digital Ship, to explain more.
So we're going to talk today about a hull cleaning device, which is much less complex and inexpensive than using robots. And it's been shown to lead to a 5% fuel reduction by a shipping company that uses it. So most of us by now, I think, have seen these sophisticated robots which crawl under the hull, under the water, and clean it with rotating brushes. We know about human divers to clean the hull. So this is a simpler way of doing much of the same thing without any rotating mechanical brushes. The device is called the ITCH, and it's made by Shipshave of Stavanger. It doesn't replace robotic or diver cleaning completely, but it means you don't need so much robotic cleaning. So perhaps you only need conventional robotic cleaning in the parts of the hull which the ITCH can't cover, and you only need robotic cleaning once a year, so that's quite a big saving. This device can be used frequently by the crew to remove light fouling. We can call that slime. And by doing this, it can prevent the growth of heavier fouling, and it can be used on any coating. Now, we're going to hear about a customer's experience with the Shipshave ITCH in this webinar. Torvald Klaveness of Oslo. They operate and manage 16 combination carriers, and they've been using the device on 4 of them for some time, and they recently acquired another 5. We have Anders Soheim, Sustainability and CO2 Performance Manager. He's going to show some videos from a camera fitted on board an ITCH device which show it cleaning, and he's also going to show how Klaveness quantifies the benefits, and they can be 5% reduction in fuel consumption. But first, we're going to get an outline of ITCH from Erik Eder, who's the Chief Commercial Officer and co-owner of Shipshave. So I'd like to invite Erik to start his talk. Cheers.
Thank you very much for the invite, Carl. I appreciate it, and I look forward to telling the audience more of Shipshave's ITCH, and I will start my presentation.
Yep, looks good.
Yeah, so today the seafarers of the global fleet of vessels is not impacting the hull efficiency, but with Shipshave ITCH on board, your crew or the seafarers can optimize the hull efficiency. All they need to do is unbox the ITCH and use it to maintain the CII rating. And yeah, I hope that when I done my presentation, you will have a better understanding of how the in-transit cleaning of hull solution works. And first, I will run an introductory film.
Clean hulls is the largest efficiency challenge in shipping. Hull fouling increases viscous resistance. Degraded hull hydrodynamics increases the fuel consumption significantly and leads to increased CO2 emissions. Biofouling develops just hours after a ship is deployed in the sea and is the main carrier of invasive species along our coastlines. Beginning as a slimy layer, the volume of organisms grows until advanced species like barnacles develop. Preventive hull cleaning will reduce the risk of species being transported from one aquatic biotope to another, but powerful cleaning systems can cause paint roughness and increased hull drag. A better solution is to let the fouling vanish in deep waters, where it sinks to the bottom without causing harm. That's why we created the Shipshave ITCH in-transit cleaning of hulls. The lightweight ITCH plug-and-play system is a semi-autonomous hull cleaning robot that harvests propulsion energy to clean the hull underwater. It is so user-friendly that it can be installed and operated by the vessel's crew during sailing. ITCH removes all types of biofouling. The controlled forces and soft brushes cause minimal wear to anti-fouling paint, allowing more frequent cleaning. First, secure the winch on the forecastle deck and provide power outlet. Deploy the ITCH robot. The ITCH seeks the hull and immediately starts sweeping by harvesting the ship's propulsion energy. Soft brushes move up and down the hull in a defined pattern with controlled brush forces. The unit's tail camera allows you to witness the process and also inspect the hull. You may discover hull inefficiencies beyond fouling. Once completed, swap sides of the tow bar and redeploy on the other side. Shipshave ITCH is ready for hull cleaning whenever you are. The potential savings are considerable. Clean proactively and save fuel. Forget downtime sailing to approved ports. Eliminate high-costs contractors and let the crew operate. Save hull inspection costs with onboard video camera. Stop spreading of invasive species. And reduce CO2 emissions. Innovation takes courage, and we have moved boundaries before. We have what it takes to change the future. Our job is to redefine hull maintenance and make shipping more sustainable. Your job is to unbox the ITCH and use it. Read more about our innovations at shipshave.no/itch.
Yeah, so a quick introduction to our company. Shipshave was founded a little bit more than 3 years ago, and the last 2 years we've been in commercial phase with the first sale of our pilot to Klaveness, represented by Anders here. Today we're 9 employees, and we have today 20 different buying customers, and more than 50% of those customers are repeat customers. I will not spend too much time on the incentives of grooming. It's so obvious, 1, 2, and 3. I think item 4 here could be more interesting to discuss, but Shipshave is a young company. No buyer has gone this route, whereas I believe down the timeline, no paint will be allowed to release anything into the water. And if you have a hard coating, then you need to clean very frequently. Yeah, it remains to be seen if I'm correct on that, but I think that's where the industry is heading. So to paint the back carpet of what the operators or owners of vessels are up against, the consumption of handy-sized bulk carriers steaming for 22 days in any given month, burning 30 tons per day, and let's say the fuel price is 600 tons. Now, not long ago, it was $1,000 per ton, and when we're talking about new fuels, surely the fuel cost will be higher than that. So Shipshave ITCH, of course, does not discriminate on fuel. It just reduces the resistance. So what does this sort of picture, how much does it cost an operator of a handy-sized bulker? And if we look at the yellow line, which represents the current fuel price, if you're down at circa 1 to 3% overconsumption, then you're probably still not able to identify that there is an overconsumption. And then you move to the right to 3 to 5%, then red flags are being raised. There's something with this vessel is consuming more than usual. And then quite quickly you can end up at 10%. And let's use that as an example. That will cost $40,000 per month in overconsumption. And yeah, you can multiply that by 12, and that's a considerable amount due to overconsumption. I will not spend too much time on this, as Anders will touch on that, but this is one verification from a customer obtaining savings using ITCH. This is another one that DNV has cemented, where a doctor has done calculations based on figures obtained from the captain, and they highlighted that the vessel had a speed gain and a fuel consumption reduction of 10% after using ITCH. We do not focus too much on the numerical value of 10, because we know that if you implement measures, identical measures on two sister vessels, the likelihood of you getting two different answers is great. What we say is that DNV has solidified that there is a saving using ITCH. We don't focus too much on the numerical value, but there's a saving. Now, the industry is not yet capable of defining what is grooming and what is retroactive cleaning. And I think retroactive cleaning is what will be more and more difficult to arrange in the future. No ports wants to have a vessel cleaned at their shores. So I think it's time that the industry define grooming, and that is what ITCH is about. It's a micro fouling level, sometimes called slime. And when you scale off the slime on the hull, there's no damage to the surroundings. But of course, with a proactive action, you're looking at a totally different frequency than what the industry is today performing. Let's say it was mentioned in the introduction that you could do a hull cleaning once a year. That to me is retroactive hull cleaning. Then you're removing macro fouling. But with the ITCH, you might have to do it as much as 12 times a year. That's depending on the coating on the vessel, trading pattern, and of course sailing frequency. So it's a complex matter, and these are sort of topics that I would like to discuss. This is a typical example of a grooming. Grooming, as said, is when you proactively remove slime before it becomes fouling. And when you look at the image now on the screen, before I start the film, it appears that there is no slime on the hull. And this hull was had a new coat of paint in June. And this film is from October, so circa 4 months in the water and in operation. The owner said, now there's slime, we will remove it. But and I think this is where the industry is sort of tricking itself, because if you inspect a hull where it's 100% covered in slime of a static unit, then you will see no slime, as this image indicates. But when you remove part of the slime, you will see a delta, and this line represents that delta. Here is no slime, here is still slime, and this slime is costing money. It's not the big drag, but if this is developed into more settled fouling, as this is the food for the fouling, then the cost increase, of course. This vessel has used ITCH now for more than a year, and there's still no fouling on the hull. And now I will show an example of what I call retroactive cleaning, because we know that some vessels has fouling and need aid to remove it. So we are experimenting with other types of brushes. These are not the same brushes as in the previous film. These are harder brushes to be able to remove settled fouling. Now, this is a large lady from one of the major container operators, and they immediately logged a 10% saving in fuel consumption. And 4 months after the operation, the vessel was still logging 10% savings, and that amounts to 10 tons of fuel per day. That's significant money, and if you do a return on investment, it will be done in a week if you buy each. Now, I don't think I will spend too much of this collective time, other than to show exactly what the unit looks like. It is 1.5 meters long and weighs less than 5 kilos. So it's not a big unit. It's easily hand carried by the seafarers, the crew members, and it's the basic for all the engineering is simplicity in use. Now, just to round this off, I wish how to communicate to the audience that the brush is soft and does not damage the paint. You can imagine the force applied by the thumb is not great. And this is not responsible for damage of any coating. On the flip side of that, this soft brush cannot remove established fouling. This is a soft brush. So let's say if you remember the film from the container vessel, this brush cannot remove that sort of fouling. Then we need to use harder brushes. So I'll limit myself to this short presentation as an introduction. This is the whole Shipshave team. This is on a beach just outside Stavanger. And I can assure you the water was not warm. Thank you.
Oh, thank you very much, Eirik. So now we're going to hear from Anders Sorheim from Klaveness.
Yes, thank you, Carl. And thank you, Eirik, for a good summary of your technology. So my name is Anders Sorheim. I'm the Sustainability and CO2 Performance Manager here in Torvald Klaveness. I work in the ship management part of the company, but we're sitting right next to the ship owning part of the company, KCC, which owns and operates 16 combination carriers. I thought I could share a small presentation as well. So let's see if I can manage to do that.
Yep, looks good.
Yep. So first of all, back to why we were looking at new technologies to help us with hull fouling. It is a big challenge, both, I guess, in short sea shipping, but also in deep sea shipping. And we've seen that it can lead to up to 40% overconsumption of fuel. And this is very costly, and we have not yet identified a silver bullet. There's lots of things that can help, but not one thing that can fix it. So we know that increased hull fouling leads to added viscous resistance through the water, which adds to the fuel consumption, worsening the performance and increasing the CO2 emissions. And we need to focus on both the prevention, the detection, and the removal of biofouling from hulls and propellers to be able to decrease our CO2 emissions from hull fouling. So I've tried to split these three focus areas in prevention, detection, and removal. So first we have prevention. Of course, anti-fouling coatings work well, at least in the first part of the period after it's been applied. We also know that at the 4th or 5th year since dry docking, the anti-fouling coating is not as efficient as it was in the beginning. We sometimes use self-polishing operations to avoid the buildup of slime, such as going full speed for an hour and 1 hour back if the vessel has been idling for a long period. So we also try to avoid long idling times. But despite all this, the ships will be idling either outside port or in port. And we want to have a tool that can help us shake off this initial to prevent further hull fouling. And where we have placed Shipshave ITCH as one of our most important tools to do that. Of course, detection of growth is also important. We use currently noon report data as well as high frequency sensor data for those vessels that have been installed with that. And we do different types of data analysis and data visualization to help us see if a vessel is consuming more fuel than it should, and therefore is probably an indicator of hull fouling. And of course, removal of hull fouling can be done in port by manual cleaners. We can do it using all the types of hull cleaning robots that we see coming to the market, as well as increase or decrease the docking interval as we have done from 5 years to 2.5 years, where we go into dry dock and kind of retouch the paint. So a little bit about how Shipshave and Klaveness have worked together over the last couple of years. We first established contact the summer of, or maybe August 2020. That's when I started my position in Klaveness, and I had come across some good, I would say, advertisement about Shipshave. So I wanted to check them out. We got a very good conversation, and a few months later, we had our first pilot agreement for the first ITCH. This was then delivered on the vessel Ballard as a pilot ship, where we started testing it. After about half a year, we saw that this is doing some good. Still didn't really know how good, as Eirik mentioned. It's a little bit hard to quantify, but we were sure that we wanted to get more of these Shipshave ITCH robots. So we signed a letter of intent for a fleet-wide rollout. Then we got a second ITCH for Baru. We got a third ITCH for the vessel Barracuda, and a fourth ITCH to vessel Bakkedal. So those 4 vessels have been sort of our pilot vessels, and we operated them throughout 2022, and gained enough data to do some proper analysis as best as we can with the data we have available, and made an additional order for 5 ITCH robots to cover the entire Clean Blue fleet that we have. And now we're excited to join as a partner with Shipshave in their ITCH performance project, where they are seeing what more can this little semi-autonomous robot do to help us not only clean the vessels, but map what the status of the fouling is on each vessel is being used on. I also thought I could share some photos of the ITCH operation from the pilot vessel Ballard. So here, I have to say in advance, this was a bit of a stage photo shoot. So that's why they're posing for us. But the crews are very excited to do this and operate this and see the actual savings in fuel. So here they are on deck with the captain, putting together the Shipshave ITCH, getting it ready to throw overboard, where they lower it into the sea, and it's starting to do its cleaning. So we also have a video that I wanted to share. It's basically the same thing, but from a different vessel, the Baru. And I think this was one of the first times they tried it out. So let's see. As this was the first time they operated this on the vessel Baru, there were 4 people helping out, but in regular use, we see that only 2 crew members is necessary to operate this. So here they're lowering it into the ocean. touches water. And it starts cleaning right away. And even though this was a pretty smooth hull, not much fouling, we can still see that the brushes are able to wash away some of the very light fouling, but light slime. So it's not so exciting to look at the hull that's pretty clean already. So I thought we could also have a look at another hull that's not so clean. Here we see a lot more slime, even seagrass. There's a lot of residue coming off. So that was the operation part. Now a little bit to how we have tried to analyze the performance of the Shipshave ITCH by looking at the fuel performance of the vessels. So here you see an example of a Power BI dashboard that we have built internally, where we show an overview of the hull and propeller cleaning, idling periods. We have some KPIs that we use to decide whether a ship needs cleaning or not. We can also see the performance over time in the lower right corner. As you can see, the performance spikes and it goes a lot up and down. There's a lot of variability. These are noon report data, and that also limits our accuracy in determining how well the Shipshave ITCH is performing. So that's why we've had to try to look at it from different angles and like exactly how will we assess the efficiency of Shipshave ITCH. We have done some comparisons over time with sister vessels. So here you see on the top the performance over time from Ballard, which was the pilot vessel, compared to its sister vessel Baffin. And they're both measured between the last hull cleaning and the dry docking. And what we saw is that the average performance over this period of time for vessel Ballard was 20%, and the average performance was about 25.8% for Baffin. Actually, when we're talking about performance, we're talking about overconsumption of fuel. So it sort of looks like that Ballard performed 5.6% better than Baffin during that period. But it's also important to note that there are a lot of other factors that play a role when determining performance over time. It could be the amount of time waiting or idling. If a vessel has been sailing in brackish water, that also affects the biome on the hull. Speed plays a role, and lots of other factors. So it's hard to conclude on this number. We tried some other ways of looking at it. On our newest fleet, we have high frequency sensors. So we tried to do a sensor data analysis right before and right after a Shipshave ITCH operation. And here we found that there's about a 2.8% improvement in performance just from this one operation. And then we also tried to do some visual comparisons. We had Barracuda going into dry dock, so we wanted to test the Shipshave ITCH only on one side. So we tested on the starboard side, and as you can see from the photos here, you sort of see the marks of where the Shipshave has cleaned. And not surprisingly, it's the bottom part near the bilge keel that is not covered that well by the ITCH. But if we compare to the port side, we definitely see that there's a difference in dried slime. So it looks to us that it works from a visual inspection point of view. We did the same thing for vessel Bangor. She had silicone paint, and after discussing with the paint manufacturer if we could test this out on her, we tested it only on starboard side again. See a pretty smooth hull. Some areas where it hasn't, the Shipshave ITCH hasn't reached entirely, but if we compare it to the port side, it looks considerably much better. So that's another indicator that the ITCH is doing a good job, but still a little bit inconclusive evidence for exact performance. So in summary, I think the 5 takeaways from us is that Shipshave ITCH has become a good tool in our toolbox to help preventing hull fouling. And the success of the ITCH is as much dependent on the actual robot itself as on how frequently it's being used on board and how well supported it is by the master and crew. We also see that even though we use the Shipshave ITCH, it does not eliminate the need for manual or robotic hull cleaning. That's more of a retroactive cleaning, but it can extend the cleaning intervals considerably. You don't have to clean as often when you regularly groom the hull. So we've also seen that when we see signs in our performance analysis that a vessel is starting to underperform, then we like to use the Shipshave ITCH as one of the first measures to try to remove this first layer of hull fouling. And we have seen from a lot of different approaches that the CO2 emissions, it's difficult to quantify, but it's on order between 2 and 5%. So the title of this webinar might be a little bit misleading. 5% is at the top end of the uncertainty range. So we would like to just say between 2 and 5%. That's what I have today. Thank you very much for watching. And I'm sure that if there's any questions, I can help answering those.
Yeah, that's fantastic. Okay, so now we'll go to the Q&A session. So there's three questions already. Just wondering, Anders, so do you have a recommendation to the crew how often you want them to do it now you've done all this testing? And do you say is it weekly or monthly? Would you recommend to the crew? And do you want to say how long it takes them to do it as well? So.
Yeah, our recommendation is to when they've started using it. So let's say that the vessel has been dry docked, it got a new coating, brand new, for example, silicone. Then you should wait a while. Wait maybe a year or 2 years, a year and a half, or until you see that the performance is starting to drop. Then it's time to start grooming. And then we recommend to do it at every long voyage, at the start of every long voyage. In particular, if the vessel has been idling for more than 5 days or even more than 10 days, that's what we recommend. And of course, it's difficult to operate the ITCH if the weather is poor. If there's high waves or lots of wind, then it shouldn't be operated. But if it's a calm weather day, then yeah, we recommend to use it.
And
so it is
yeah. They do it out in the open ocean. It's not something you have to do in port when everybody's really busy. So I guess it might be quite easy to schedule around other work, isn't it?
Exactly. That's also an important point, that we don't want to take away the focus from the crew when they have more important operations to do, and definitely don't want to jeopardize the safety on board. So this is done on longer voyages in the beginning of those.
Oh, very good. So we've got a question from Jonathan Deeney, who I think is from Frontline Management, about asking about weather limitations. So I guess if it's really stormy, they don't want to go out on deck, but otherwise you can Well, I suppose they want to go out in the rain. There've got to be people outside. Is that the main?
Yeah. Well, maybe Eirik, you have, because we do what Shipshave recommends us to do. And,
yeah, what we say on the current limitations, and I make a point of saying the current limitation is that as we learn from the users every day, so we hope to expand the current limitations. But today we say that the itch should be operated when the wave height is less than 3 meters. But already we learned that, let's say, if the waves come in on port side, then you may run it at a higher sea state on starboard side, on the lee side, than on the weather side. But we need more data and user collaboration to cement that. But so today it's 3 meter wave height is the limit.
And it's underneath the waves a lot of the time, isn't it? So does that make any difference?
But the unit is using water pressure to determine the depth it's working at, and a 5 meter swell will of course impact the depth that the unit thinks he is on the hull. So it is impacted.
Okay, and there's a question from Valerie Gorobia, who I think is from Unity Marine. So in terms of cost, I don't know, I don't want to push you to say anything that's not secret, but I don't know if it's $10,000 or $1 million. I don't know if you can give any.
I can say somewhere in between.
Somewhere in between. Is that as specific as we want to go?
If I can refer to the slide that I showed on the monthly cost for overconsumption on a handy-sized bulker, is in that range for 1 month of overconsumption at 10%.
Yeah. Well, I think I did a back of an envelope calculation of $35,000 from the return on investment numbers, I think, but yeah.
Yeah, I can also say from our side that we when we did the business case for rolling out the Shipshave ITCH, we used a saving potential of 1% because we want to be quite conservative, and even with that, we have a very solid business case.
Oh yeah, I mean, we often hear shipping companies say you want at least 2% benefit to be worth the while of all the effort, isn't it? Because 1% is kind of lost in the noise, isn't it? I suppose, but if you're sure it's 1%, that's worth.
Well, I'm trying to be very, very conservative when we do these business cases, especially since we don't have like a very solid, accurate answer. But from the analysis as I went through, we do suspect that the real number is between 2 and 5% somewhere. But just for the business case, we assumed 1%.
Oh, if I may add something there, I mean, if the participants in this webinar are all from shipping, as assumed that, then we know that shipping is not too keen to share information. So most of our buyers are not sharing the savings obtained. But as I said in my slide, more than 50% are returning customers. So at some point they must have done a calculation outweighing the investment in the savings. But we really hope that more buyers will share openly, like Anders and Klaveness has done. It's key for us to sort of convince the buyers that there is savings involved. So we urge any buyer to share this with us, but of course we cannot force anybody.
Oh, okay. Got a very commercially sensitive question here at the top. My colleague says it's a Sangtai hand from SK Shipping asking about the customer list. I mean, I guess you can't reveal any customers apart from Klaveness, but is there anything else you mentioned? A container shipping customer you want to say?
I'm happy to share the entities' names of those who publicly has announced purchase. And Odfjell in Bergen is currently our biggest customer, and Klaveness is a big customer and has played a crucial role for the development of ITCH. And Stolt Tankers is a big customer of ours. So yeah, and also we have oil companies, and soon I think we will have big charterers of bulk vessels as client too. But some are on the stock exchange and does not allow us to share their entities' names.
Oh, very good. Then Anders, do you want to look at this question from Roland? So Roland works for a company called Tokua, which makes models for ship performance. He put this question up before you gave your slides, and I think you partly answered he's asking about how your performance models work and how you normalize the noise. I think the answer is very difficult, but you managed to show some ways of doing it. I don't know if there's anything else you want to add to what you gave in the presentation to that one.
Well, it's absolutely true. So using noon report data, the accuracy is very low, lots of noise, lots. And as we're moving from noon report data to high frequency sensor data, we reduce some of that noise, increase the accuracy. But we are in discussions with third-party companies such as Tokua about helping us use machine learning and AI to reduce even further the noise and get a more accurate answer.
Oh, very good. A question here from Jean Popper for you, Eirik. What's the contacts for ordering? So Jean or John is from V-Ships. I know you've got 9 employees, so I can't imagine you're too hard to find, but we'll give your email address out to everyone who registered if you're happy with that, or you can.
Yeah, that is perfectly fine. But for quick reference, it's sales@shipshave.no.
Oh, there we go. Sales@shipshave.no. Very good. Question from Christopher Stenison, who's from Rediret Stenison in Bergen, asking about explosion proof on tankers. Is that for you, Anders? Is that something you were concerned about? I don't know if your combination carriers have to.
Yeah, we were a little concerned about that. So that's why we have ordered the pneumatic winches. So they run on compressed air instead of electricity. But I know that Eirik and Shipshave has done some developments on that area as well.
Yeah, what I find is that the industry is not practicing the same uniform procedures or regulations. And I am a mariner too, and I have a hard time understanding how the forecastle deck can be classed as explosive zone, given that the anchor chain will generate sparks when you run it out. But Anders is correct. Some of the vessels designed to carry hydrocarbons has a tendency to want to purchase the pneumatic winch, and that's an air winch. And I think maybe it's not so much that the forecastle deck is defined as an explosive zone, but let's say for an audit, it could be easier just to, there's a pneumatic winch, not an electric winch, but we have delivered numerous electric winches to product tankers, to chemical tankers, to LNG tankers. So we just deliver what the client wants and ask no questions.
I can also mention that from the position that the crew is operating the winch, you're outside of the EX zones. So just the forecastle deck.
Oh, very good. And there's a question for Eirik from ACJ, who's from Vessel Performance Solutions, asking about propeller polishes. So I think he's talking about sort of some kind of robotic cleaning that goes round and round like a propeller, which I imagine you're not doing because you're specifically doing this sort of low tech approach. Is that the right answer?
Yeah, the itch for obvious reasons cannot get to the propeller when as the itch is used.
Oh, cleaning the propeller itself,
when the
right?
Vessel is sailing.
Oh, okay.
So the propeller will have to be cleaned when the vessel is static, and we have a internal project going on a solution that should be equally easy for the seafarers to use, also on the propeller, but that is further down the timeline.
Okay, I thought propeller polishing was a certain type of polishing. I think yeah, very good. So there's a question, or 2 questions now, the same about the bottom as well as the side. So it doesn't clean the bottom. That's what you use robotic cleaning for. Do you want to maybe both? I mean, I suppose there's not much more to say about this.
I can start out, and yes, this is one of the disadvantages of the itch. It cannot go beyond the bilge keel, and sometimes it doesn't really go all the way down to the bilge keel. It also doesn't cover the bulb or the bulbous bow. And it doesn't cover the very aft of the vessel. So it's mainly for the vertical side hulls. But that's also where most of the fouling is. And we also see that on the bottom of the hull, that's where it's the least fouling due to the amount of light reaching there. But of course, as I mentioned in my presentation, we need to do actual manual cleanings in port, but not as often. And it's also nice to, like, in between the cleanings, we can keep the performance good by using the itch, and then when we go into port, we clean the parts that cannot be cleaned by the itch.
And I think Anders summarized it well in his presentation. There is no silver bullet today, and Shipshave, we do not claim to be the only solution. But what we can do is, as Anders said, reduce the time spent on the areas that the itch cannot clean. But having said that, there's no reason why the itch should not be able to do the flat bottom, but it will take a lot of coding and testing before we can sell itch as a unit that can clean the flat bottom. But it is on our to-do list, and at some point in time, the itch will also clean the flat bottom.
Yeah, you'd have to have a different way of suspending it from the forecastle, wouldn't you? I mean, I don't know how you get it under the bottom.
The challenge is what is generating the sweeping motion is delta in water pressure and the angle when it reaches the curvature at the lower parallel line. On the flat bottom, there's no delta in water pressure nor angles. So then we need to implement a new way of governing the sweeping motion. And that of course may be the easy part to solve, but it needs to be tested and cemented that it works. So, and we when we started on this journey, we had dialogues with big tanker owners here in Norway. They have proximity to our office, so we based it on that. And they were very clear: focus on the vertical side, because the other parts of the hull is very limited with fouling. And we listened.
Oh, that's great. We've got a nice question here from Jonathan of Frontline again. Maybe Anders, would you like to take this? So is there one? So how many times do you deploy it? Or is it as many times needed? Or,
yeah, normally we do, it's almost like a 2-day operation. We do 1 day per side. Well, it's not a full day, but maybe 3 hours. So you deploy it from the forecastle deck, and it slowly goes farther and farther back until it gets to its limit at the aft. So I think the limit is supposed to be at least 5 meters from the propeller, because we do not want to risk getting this itch into the propeller. And then you start rolling it in again with the winch. So it kind of covers one side of the hull twice in one operation. And that's usually sufficient.
And you've got 2 crew members the whole time on the deck, isn't it? I think.
Yeah.
And the camera feed, I think that's downloaded to be viewed later, isn't it? Yeah.
It is downloaded to be viewed later. Yeah, it would be. Yeah, it wouldn't be feasible, I think, using Bluetooth.
But it wouldn't necessarily help you to see it live. I mean, it's nice to see the camera picture, but it doesn't really.
Yeah, the videos are nice for showing the effect of it. It's nice to evaluate the status of hull fouling on a ship, but it's more for post-processing and data analysis, performance analysis.
Yeah, oh, that's great. Just from me, so I'm quite interested, but thinking about cleaning, because that's the important part of this. I guess maybe as human beings, we always go to the most complicated, robotic, sophisticated device like dishwashers in our homes. It always amazes me how easy it is to clean dishes with just a rag with no abrasion at all. But I suppose this is the kind of thinking that we're getting into here. You can clean a lot of things quite easily if you do it early and frequently, and it's a different way of thinking about cleaning. I suppose that's. I quite like the point about you said slime is the food for the fouling. So the slime is what the heaviest stuff eats on. So if you get rid of the slime, then I don't know if there's any comment you want to make about that.
No, it's true. The bacteria and the single-celled organisms are the first ones to attach to the hull, and that can happen within minutes after something is put in the water. And then when it's starting to grow and spread, algae come and start eating the bacteria. And then if enough time is passed, then bigger animals can come there to eat the algae. And also the seagrass can take root and start growing. And of course, barnacles, which we really, really do not want.
Yeah. It's a
We
question.
say it quite easily, Carl. Start with a clean hull and keep it clean. That
Yeah,
takes much less effort than if you get to the barnacle stage, then you have trouble, because that is difficult to get off even in dry dock.
Yeah, and that's an important message for the crew, I suppose, isn't it? They sort of take it as something that needs to be done regularly, every couple of weeks. And
I think the biggest mistake you can do with itch is not to use it.
yeah. Oh,
but one advice from our side is that the crew and the masters need to be heavily involved in this and have to be trained properly. There has to be proper handover procedures from one crew to the next. They need to understand how important this is, and yeah, we need also to support them heavily from office side.
That's an excellent point, Anders, and I would like to elaborate on that. Of all the users we see, is that where the buyer, I mean, it's sort of a tripartite relationship. There's a buyer, which is represented by Anders, and there's the users, the seafarers on the vessel, and me as a supplier. And without a motivated user, our innovation is of no use. And our contribution in that equation is to make it as simple as possible. So remove the fear factor of a new and innovative tool, but it needs to be followed up from the shore organization. And we see that the likes of Klaveness, who has everything in-house, is higher success than the likes of buyers, who everything is a third party service. So it needs a motivated user.
well, you must have a planned maintenance system, Anders. Would you get this into the planned maintenance system, or is that all for pumps and engines? And
Yeah, this has not come into the planned maintenance system yet.
Okay.
Perhaps in the future at some point.
So some of our buyers has it in the PMS, and I think that's where it belongs, because that creates a commitment between the shore management and the crew on board on frequency, and that needs to be done.
Yeah, we have included this the use of Shipshave into our QMS, so the quality management system, specifically into our voyage procedures.
Oh, that's great. There's a question here from Sangtai Han of SK Shipping asking about retrofitting equipment. I think he or she's talking about the winch on board the forecastle. That's the only equipment you have to retrofit, is it?
There's no fitting involved, and no approvals from class. It's just unbox, connect to power, and use.
Yeah.
Well, the winch, though, can you use a winch you've already got, is it?
No, you need to, and Shipshave has no desire to sell winches, just to be honest about that. But we see that the winches that the vessels are equipped with, mooring winch and anchor winch, is too brutal and not controllable enough. There's no automation on them. And the key for the winch speed is that it's slow enough to allow for the unit to have overlapping swipes. If not, you will have a pattern on the hull. So it needs to be really slow, and I suspect that the winch speed that Anders' fleet is working on is between 1 and 3 meters per minute. And that is not possible to obtain with the mooring winch.
Yeah. But I can mention that the winches that we use are portable, so they're not, you don't fix them to the ship itself. The very first project that we did, the pilot project, then we actually welded a winch to the forecastle deck. But after that, Shipshave came up with, or found a better solution with these portable winches.
Oh, but they're bolted on. They must need a lot of force to hold them on, do they? Oh.
The winch only pulls with 150 kilos and weighs
right,
less than 50 kilos. So it's not a big tool. And so it only needs to be secured to a strong point with the same rope as is on the drum. So there's no fitting or mounting anything.
Well, we're getting a lot of questions from Oslo today, but this is Eirik Renning, who's operations manager of DH Tankers in Oslo, asking about what type of anti-fouling can it use on a self-polishing type of anti-fouling? I think you said you can use it on any coating at all. But you want to...
Well, we were a little bit worried in the beginning, and we still are, about the very soft type of foulings, such as silicone. Silicone paint gets easily damaged by physical, meats or so we have done one test on a silicone painted hull, and that turned out to be quite good. We didn't see any brush marks on the silicone itself, but I would still, if you have a paint that you're worried about, then I wouldn't just deploy the itch without talking to the paint manufacturer first and discussing.
Yeah, any paint that's tough enough for a ship ought to be soft enough for those brushes, or able to handle those soft brushes, isn't it?
Yeah, I think silicone is a little special. So we still don't dare to use the Shipshave ITCH on a new vessel with, or a dry docked vessel with new silicone paint.
And what Anders is saying is sort of cemented by the supplier or the biggest supplier of silicone paint. And they say that on a well-functioning silicone paint application, you should not use any cleaning method, not just itch, but you should not use any cleaning agent on a functioning silicone paint. But they too know that after 3 years, a high number of the applications fail and do not operate as intended. Then they have said that itch is a very good tool to enhance the silicone. What the silicone is sensitive to is mechanical wear. And the itch brush have not identified any mechanical wear to the silicone paint. We hope to get down to the micro level with this supplier and to be able to rule out any wear to the paint. But it takes time.
Well, that's fantastic. Well, we're coming to the end of our time now. I don't know if you want to take a minute, Eirik, to see lasting words to the audience or anything. But any final thing you'd like to say in the last minute or so? Well,
yeah, I just want to express gratitude to Klaveness having played a vital role in the further development and improvement and simplification of ITCH. So we are very grateful for the collaboration that we have had with Klaveness, who is a proactive owner in the forefront in shipping, I think.
Well, and Anders, you've got one more question from Sankte Han asking the name of the paint manufacturer, but I don't know if you want to reveal that or not. Is that a...
I think Eirik said that.
We'll put that on a private email perhaps after. Yeah, that's great. Well, thanks ever so much. That's been fantastic. I think we've shown some new story about how we're doing this, and it's great to hear how we're using it. And I shall pass back to Farah for the closing words. Cheers.
Thank you to our guest speakers, Eirik Eide from Shipshave and Anders Suheim from Klaveness, and to all our viewers. We'll be sending you a YouTube video link soon with their contact details if you have any further questions. Join us for our next webinar this Thursday on the 9th of March with Digital Ship and Tech Play called How Vopak Improved Predictability in Marine Operations, Efficiency for the Terminal and Vessels Know When to Arrive. You can book this online at our website. Goodbye.
Bye-bye.
Thank you.